In the subject of analog electronics, the topic is the photo transistor and LDR or light emitting diode. Basically, these are the device of semiconductors and used in semiconductor and electronics engineering. So what is the photo transistor? The phototransistor is a semiconductor light sensor formed from a basic transistor with transparent cover that provide much better sensitivity than a photodiode. Basically, it is the semiconductor device, and the construction and the function is the as similar to the basic PNP transistor. So in which phototransistor there are three layers and phototransistor structure. One is the N layer, second is the P layer, and again is the N layer. So there are three layers, and these layers are also as a collector layers, base layer, and emitter layer. So phototransistor has much larger base and collector area than would be used to normal transistor. So the in phototransistor structure, the area of collector region is the large as compared to the emitter region. So these devices were generally made using diffusion or ion implantation. So then the structure of phototransistor, generally the diffusion process and ion implantation technique is used for the phototransistor made the structure. Early phototransistor base germanium or silicon throughout the device, which is these are the two types semiconductors materials, germanium or silicon. That is the generally used for to construct or structure for the phototransistor, and throughout the device giving a homo junction structure. The more modern phototransistor use type 3 and 5 materials such as gallium arsenide. These are the type 3 materials, and phosphorus is the example of type 5 material, which is generally used for the phototransistor structure purpose. Structure that use different materials either side of the PN junction. So there are also a PN junction formation because there are the different layers of N-type, P-type materials, so that there are a junction formation. And junction are also popular because they provide a high conversion efficiency. So these are generally fabricated using epitaxial growth of materials that have matching lattice structure. So these phototransistors generally use a MESA structures. Sometimes Schottky metal semiconductor, this is the also semiconductor diode. Junction can be used for the collector within a phototransistor. So the collector is the one terminal of the phototransistor. As a collector terminal, sometime we use Schottky diode junction as a collector terminal. Although this practice is less common these days because other structures offer better levels of performance. So in the phototransistor, in order to ensure the optimum conversion and hence sensitivity, the emitter contact is often offset within the phototransistor structure. You we see in this diagram, here is the emitter part, emitter terminal, base terminal, and collector, and is the uh, N plus gallium arsenide layers, and also here is light fall upon the emitter or surface of the emitter. So the emitter contact is often offset within the phototransistor structure. So this ensures that the maximum amount of light reach the active region within the phototransistor. Because there are different regions in phototransistor, what we want to ensure that the maximum amount of light reaches the active region within the phototransistor, because the phototransistor operate in the active region or linear region. So in phototransistor operation, the phototransistor are operated in their active regions or in linear region. For operation, the bias condition are quite simple. The collector of an NPN transistor is made positive with respect to the emitter or negative for PNP transistor. So there are basically divided in two types. One is PNP transistor, in which made positive with respect to emitter or negative for the PNP transistor. So the light enters the base region of the phototransistor, where it causes hole electron pairs to be generated, because the generation of hole and electron pair generate the current, and that current flow in the phototransistor. This mainly occurs in the reverse bias base collector region, because we have the base and collector junction as a reverse bias condition. It means that the reverse bias means the positive terminal of the phototransistor is connected to the negative terminal of the battery, and positive terminal of battery connected to the negative terminal of the phototransistor. So this is the symbol here of the phototransistor, in which there are total three terminals. One is base, and the second one is emitter, and third one is collector. So the flat spot and shorter pin indicate the emitter terminal here. So light is fall upon the emitter terminal. So here also a generation of hole and electron pair, and due to the generation of hole and electron pairs, the current flow in the phototransistor. The hole electron pairs move under the influence of the electric field and provide the base current. Because the generation of hole and electron pair occur when we applied the electric field to the in the manner of biasing, reverse biasing condition to the phototransistor, and provide the base current, causing electrons to be injected into the emitter. There are flow of electrons and inject into the emitter region. Characteristics of phototransistor. Characteristics means the graph between, we want to draw the graph between the current versus voltage, which is flow in the phototransistor. So phototransistor has a high level of gain resulting from the transistor action or homostructure, because the structure of phototransistor is the homostructure, one using the same material throughout the device. In this phototransistor, the same material is used throughout the device. So this may be of the order of about 50 up to few hundred. However, for the heterostructure device, the levels of gain may rise to 10,000 Despite their high level of gain, the heterostructure devices are not widely used because they are considerably more costly to make manufacture. So the characteristics of the phototransistor under different light intensities, they are very similar to the characteristics of the conventional bipolar or BJT transistor. Uh, what with the different levels of base current replaced by the different levels of light intensity, because in the BJT the base in that BJT, the base current is here replaced by the light intensity in the phototransistor. So there is a small amount of current that flow in the phototransistor even when no light is present. So this current is called the dark current, or and this current represented by the very small number of carriers flow due to the temperature, and the range of this current will be very minimum in the range of micro ampere or nano ampere. So this is the dark current or reverse saturation current, which is flow in the absence of the any applying the biasing to the phototransistor. And what is the advantage of photo transistor? Uh, so a further advantage of all photo transistor when compared to the avalanche photodiode, another device that offers gain, is that the photo transistor has a much lower level of noise, because this is the advantage of the phototransistor, because in phototransistor the noise level is very low as compared to the other photodiode or other transistor semi conductor devices. So this is the one of the best advantage as compared to other semiconductor device. There are many disadvantages as compared to advantage. One of the main disadvantage of the phototransistor is the fact that it does not have particular good high frequency response. So the frequency response of the photo transistor is very poor. So this arises from the large capacitance associated with the base collector junction, because there is the presence of capacitance effect across the base collector junction region. So this junction is designed to be relatively large to enable to pick up sufficient quantities of light. So we keep the uh, large surface of the collector to pick up for the sufficient quantity of light. For a typical homostructure device, the bandwidth may be limited to about 250 kilohertz. Heterojunction device have a much higher limit, and some can be operated at frequency as high as 1 gigahertz. So this is the very high frequency, 1 gigahertz. This is basically microwave frequency and used for microwave applications. Here is the photo transistor symbol. We can represent by this symbol of the photo transistor device. And the photo transistor symbol for use in electronic circuit diagram is very straightforward. It is formed from the basic transistor symbol with arrow point into the indicate that is light sensitive, which is indicate in the by the arrow, and one arrow also indicate the flow of charge carriers, which is indicated in the emitter region. So the phototransistor symbol often has two arrows pointing toward it, and what other phototransistor symbolic show a jagged arrow. Both versions of the phototransistor symbols are acceptable and understood. So this is the basic symbol of phototransistors. The phototransistor circuit configuration. In configuration of phototransistor circuit, the phototransistor can be used in variety of different circuit configuration. Like more conventional transistors, the phototransistor can be used in common emitter and common collector circuits. This is the two mode of circuits, common emitter and common collector. Common emitter means the emitter is common between the input and output terminal, and also the common collector means the collector is common between input and output terminals. So the common base circuit are not normally used because the base connection is often left floating. So there are only two type connection generally used in phototransistor circuit. One is the common emitter and second one is the common collector circuit. What a normal PNP or NPN transistor, the three mode of operation or three mode of configuration are generally used. First one is common base, second one is common collector, and third one is the common emitter. So in phototransistor, only two configuration is used, generally common emitter and a common circuit, in which the base connection is often left floating condition. So there is no common base connections. The choice of common emitter or common collector phototransistors circuit configuration depend upon the requirement for the circuit. The two phototransistor circuit configuration has slightly different operating characteristics, and these may be determine the circuit used. First, common emitter phototransistor circuit. So there is the common emitter between the input and output terminals and input or output connections. So the common emitter phototransistor circuit configuration is possibly the most widely used. This is this connection is widely used in phototransistor circuit. Like its more conventional state transistor circuit, the collector is taken to the supply voltage by a collector load transistor, and generally supplies the DC supply, that is the BCC, and BCC means DC supply across the collector terminal of the phototransistor. So the circuit generates an output that's moved from high voltage state to low voltage state when light is detected. So the circuit actually act as an amplifier. Or amplifier, what is the amplifier? The amplifier means increase the strength of the weak signal to a high level signals. So circuit actually act as a amplifier, or the current generated by the light affects the base region. So this amplified by the current gain of the transistor in the normal way. Here the current gain also amplified. So this is the circuit uh, diagram representation of the common emitter in phototransistor circuits. But in common collector phototransistor circuit, this is the second uh, type of connection of the phototransistor circuits, common collector, in which collector is common between the input terminal and output terminal or input circuit to the output circuit. The common collector or emitter follower also called as a voltage follower. So the gain of the emitter follower generally must be equal to unity. Phototransistor circuit configuration has effectively the same topology as a normal common emitter transistor circuit. The topology is the same of the common collector phototransistor circuit as the simple PNP BJT transistor circuit. The emitter is taken to ground by a load resistors. You can see this in this circuit diagram. The emitter is grounded and the collector is supplied by the DC voltage VCC, and the output of circuit being taken from the emitter connection of this device. So the circuit generates an output that moves from the low state to high state when light is detected. So this is the uh, common collector phototransistor circuit specifications or explanation. Now, what is the phototransistor circuit operation? Then the phototransistor circuit can be used on one or two basic modes of operations. They are called active or linear mode and a switch mode. So there are generally two modes in which a phototransistor operate. One is the active mode or linear mode, and second one is the switch mode. So the operation in the linear mode or active modes provide a response that is very broadly proportional to the light stimulated. In reality, the phototransistor does not give a particular linear output to the input stimulus, and it's is for this reason that this mode of operation is more correctly termed the active modes. So this is the phototransistor circuit operation, and the operation of the phototransistor circuit in the switch mode is more widely used in view of the non-linear response of the phototransistor to light. When there is a little or no light, virtually no current will flow in the transistor. If there is no light, or if no light, so there is no current of flow in the transistor. So, and it can be said to be the off state when the current is no flow. In that case, the transistor said to be in off state when if the light fall on it and current flow. In that case, that is called as on state. However, as the level of light increase, the current start to flow because the current is depend on the intensity of light. So light increase, so the current also increase. Eventually, a point is reached where the phototransistor becomes saturated and the level of current cannot increase. So eventually a point at that the phototransistor become saturated and there is no current increase and we cannot increase the current. In this saturation, phototransistor is said to be the saturated. So the switch mode therefore has two levels. In switching mode, there have two levels. One is on and second is off, because switching have the two modes on and off as a in digital or logic system, and also in digital system 0 and 1. One is the high level or on level, and 0 is the low level or off level. Is the same in switching mode. There is a also two modes, on and off. This type of phototransistor mode is useful for the detecting objects, sending data, or reading in coders, etc. So this type of phototransistor that operate in switching mode are generally useful for the detecting objects, sending data, or reading in coder, etc. With most circuits not using the base connection, even it is available, the only way to change the mode of operation of the circuit is to change the value of the load resistor. So this is set by estimating the maximum current anticipated from the light levels encountered. Using this assumption, the following equation can be used. In active mode, the BCC is greater than RL into IC. BCC is the supply voltage or DC supply voltage, and where RL is the load resistance, or IC is the maximum anticipated current. So the in active mode, BCC is greater than RL into IC. What in switching mode, the BCC is less than RL or IC. So this is the two conditions for the active mode and the switching mode of the phototransistor circuits. So now we discuss about the working of LDR, light dependent resistor. This is the also a semiconductor device. A LDR work on the principle of photoconductivity. The principle of LDR is the work as a photoconductivity. Photoconductivity is an optical phenomena in which the material's conductivity reduced when the light is observed by the material. So that is the optical phenomena in which the conductivity reduced when the light is observed by the material. So photoconductivity is an optical phenomena in which the material conductivity reduces when light is observed by the materials. When light falls, when the photons falls on the device, the electrons, the valence band of the semiconductor materials are excited to the conduction band. So there is a movement of charge carriers from the one conduction band to another conduction band by the flow of the electrons and holes pairs or charge carriers. So these photons in the incident light should have energy greater than the band gap, because we know that the sum or energy band gap between the conduction band of valence band of the semiconductor structure. So the photon incident light, that is the condition should we have energy greater than the band gap? What is the band gap? So band gap is the distance between the valence band and conduction band. So this band gap or this distance should be less than to the energy of the photon, or photon energy should be greater than the band gap of the semiconductor materials to make the electron jump from the valence band to the conduction band. So in that case, if the incident light energy greater than the band gap, in that case the electrons jump from the valence band to conduction band conduction band. So due to the this process, the flow of electrons from one band to another band, so create the current or and develop the current to flow the from one band to another band. So when light having enough energy is incident on the device, more and more electrons are excited because the electrons generation of electrons depend on the incident energy. That energy fall on the device. So electrons are excited to the conduction band, which result in large number of charge carriers generated, and due to the large number of charge carrier generated, the large current flow due to the charge carriers. The result of this process is more and more current start flowing, and hence it is said that the resistance of the device has decreased. So in that case, the resistance of the device is decreased because this process is more and more current start flowing, and in that case the resistance of the device goes to decrease. In characteristics of the light dependent resistor LDR, so LDR are light dependent devices whose resistance decrease when light fall on them and increase in the dark. So when we fall the light on that resistance, that device LDR, so the resistance of the LDR is decreased due to the falling of lights on them and increase in the dark. So when a light dependent resistor is kept in dark, its resistance is very high. This resistance is called as a dark resistance. So this high resistance is called as the dark resistance. So it can be as high as 1012 ohm, 1012 ohm. This is the value of the dark resistance of the LDR. If the device is allowed to observe light, its resistance will decrease drastically. So then if the device is allowed to observe light, its resistance will decrease. If a constant voltage is applied to its and intensity of light is increased, so the current start increase. And we see in this graph there are the resistance versus characteristics of a LDR. So we can explain also and understand with the help of this graph. In this graph, when light is incident on a photocell, it usually takes about 8 to 12 milliseconds for the change in resistance to take place, while it take place second for the resistance to rise back again to its initial value after removal of light. This phenomena is called as resistance recovery rate. So this phenomena is also called the resistance recovery rate in the LDR system or LDR device. Now, LDR are less sensitive than photodiode and phototransistors. So, the photodiode and photocell are not the same. A photodiode is a PN junction semiconductor device that converts light to electricity, whereas photocell is a passive device. There is no PN junction nor it convert light to electricity. So this is the simple LDR is a passive device. So in passive device, there are, for example, resistance, inductance, capacitor. These are the passive devices. So this is the example of passive device, LDR, light dependent resistor. So there is no PN junction formation and not convert it light to electricity. What in the photodiode that have the PN junction semiconductor and that convert the light into electricity. So this is the basic difference between the LDR and photodiodes. If the light intensity is kept constant, the resistance may still vary significantly due to temperature change. So the resistance may be changed by varying the temperature change. So they are sensitive to temperature change as well as. So the intensity of light for keeping the constant, the resistance may be still changed with the change in temperature. So the resistance dependent on the change in temperature. So extrinsic light dependent resistor are generally designed for longer wavelength of light with a tendency toward the infrared IR. When working in the IR range, care must be taken to avoid heat buildup, which could affect measurement by changing the resistance of the device due to the thermal effects, because the value of resistance change due to the effect of the change in temperature. So this is the uh, change in resistance due to the effect of thermal. In construction of the LDR, modern light dependent resistors are made of lead sulfide, lead selenides, indium antimonide, and most commonly cadmium sulfide and cadmium selenide. So these are the some materials that use for the LDR, and a light sensitive material is deposited on an insulating substrate such as ceramic. So in this construction of LDR, the material is deposited in zigzag pattern in order to obtain the desired resistance and power. rating. So this is the method of depositing the material in the shape of zigzag pattern. This zigzag area separate the metal deposit area into two regions. Then the ohmic contact and made on the either side of the area. So this is the construction part of the LDR. The resistance of these ohmic contacts should be as less as possible to make sure that the resistance mainly change due to the effect of light only. Highly purified cadmium sulfide powder and inert binding materials are mixed. So this mixture is then pressed and centered. So this disc is then mounted in a glass envelope or encapsulated in transparent plastic to prevent surface contamination. And we can see this in that diagram in which transparent coating upper over the surface, and that is the electrode 1, and like after below this electrode 2, and one is the terminal pins here, and next one is the cadmium sulfide layer, and next to the ceramic covering. So this is the photo transistor terminals are there, two terminals. So this is the construction or structure of the LDR device. There are some advantage and disadvantage of the LDR device. LDR are generally cheap and readily available in many sizes and shapes. So the practical LDR are available in a variety of size and package styles. There are different package styles. The most popular size having a face diameter of roughly 10 millimeter, 10 millimeter. So they need very small power and voltage for the operation. So for the operation of the LDR required very small power and voltage. So this is the advantage of the LDR. And there are some disadvantage of the LDR. There is highly accurate with a response time of about tens or hundreds of milliseconds. So this is the highly inaccurate with response time that have the tens or hundreds of milliseconds. And what is the application of LDR? So one application of LDR as a light sensor. The diagram is shown in this figure. There is different value of resistance, and one is the LED device, and also one is the transistor that have the 3-terminal base collector emitter, and these are connected in the as shown in this graph. The LED light up when the intensity of the light reaching the LDR register is sufficient. So this is the condition for the LED light. And example is automatic emergency light. This is the example of that. It sense darkness or night and turn on automatically. Similar, it sense daylight and turn off automatically. Series of LED are connected. So this is the one application of LDR light sensor that sense the light, and you generally in the street light for sensing the day and night light, and this automatic sense the darkness in the night and turn on automatically, and similarly it's sense daylight and turn off automatically. So this is the light sensor using street light or road light. So this is the application of LDR. These are some books that are covers of this LDR and phototransistor topics, and there are some multi-choice questions. So light dependent resistor LDR are basically semiconductors whose resistance decrease with intensity of light. They are made of by the cadmium sulfide or cadmium selenide. So this is the very important device and very useful applications in the field of electronics engineering. And LDR generally used in many applications. Some of them are, for example, is on-off light relay. This is also used in a relay because relay have the function of as a on and off, and light meter to measure the intensity of the light, and to measure the intensity of light we use as a LDR, and soundtrack to record a modulating light intensity, and this is also the application of soundtrack to record the modulating light intensity. And for infrared detection also use as a LDR for the infrared detections, and LDR also used as a voltage regulations for controlling the voltage. So used as a voltage regulation purpose. So these are the some applications of LDRs. And the question number first, the current gain of a transistor is defined as the ratio of the collector current to the option A base current, option B emitter current, and option C supply current, and option D is the collector current. So here correct answer is the option B is the emitter current, because the gain of the transistor is the ratio of the collector current to emitter current. Next question, the graph of current gain versus collector current indicates that the current gain is constant very slightly, very significantly, and option D equal the collector current divided by the base current. So this is the correct answer is V, slightly vary the current gain. Question number third is, when the collector current increase, what does the current gain do? Decrease, stay the same, increase, any of the above. So correct answer here, increase, because the gain is proportional to the collector current. So collector current increase, so also gain of the current gain also increase. Next question, when the base resistor increase, the collector voltage will probably option A decrease, remains the same, option C as the temperature increase, and option D can be any of the above. So correct answer is the decrease, because increase the resistance and base region that affect the collector voltage. Next question, when the base resistor increase, the base resistor is very small. If the base resistor is very small, the transistor will operate in the cutoff region, active region, saturation region, do all of the above. So there are correct answer is B, active region, because generally transistor will operate in active region or linear region. So here correct answer is B. So these are the others multi-choice question that are the very important and interesting question. So thank you very much.